So guys, today I want to show you a neat little trick. Take your hand and cover your eye. Now look at an object that isn't moving, like Globe. Now take your hand and cover your other eye. See how the objects seem to have moved to a different spot? But we know that didn't actually happen. So how did it appear to move? Easy. Each one of your eyes sees the object from a different angle. Then your brain puts those two pictures together so we can figure out how far away an object really is. NASA's stereo mission uses that same idea to look at the sun. When I say stereo, I'm not talking about listening to music. I'm talking about a satellite mission NASA launched a few years ago. When we hear the term stereo, we're usually talking about two objects, such as a left and right speaker on a music system. NASA's stereo mission involves two satellites. The official name for the mission is the Solar Terrestrial Relations Observatory Mission, but everyone just calls it stereo for short. The main goal of stereo is to learn more about the sun. The two satellites are placed in different paths, or orbits, around the sun. The first satellite is in orbit moving ahead of Earth, while the second satellite is behind it. This lets NASA engineers see more of the sun at the same time. It also gives them a three-dimensional view of the sun. So why do scientists want to take cool photos of the sun? They're trying to study the huge solar explosions that happen on the sun. Some of the strongest solar eruptions are called CMEs, which stand for coronal mass ejections. Terry Kuchera is a project scientist at the NASA Goddard Space Flight Center.
Well, our main interest, the main thing that we're studying, are things called coronal mass ejections, or CMEs. And these are these giant clouds of gas that blow off the sun, and they actually blow out into the solar system, and they can reach the Earth and affect us here. They affect the spacecraft and communications and power systems, so there are practical reasons to wanting to study and understand these, in addition to actually just being interesting because the sun is a really dynamic place.
CMEs can have incredible effects on Earth. Sometimes they cause the beautiful colored lights known as the auroras that appear at the North and South Pole. But sometimes this powerful energy can have negative effects on us. These rays can be harmful to astronauts in space, or they can cause damage to spacecraft or satellites orbiting our planet. So it's really important that scientists get a better understanding of these solar eruptions that fly towards Earth. In the past, that has been very hard to do. When you have just one satellite, it's almost impossible to tell how fast the solar eruptions are moving and in exactly what direction they are coming. Here's an example of what I mean. Let's cover one of our eyes again. Now we'll bounce this ball against the wall and try to catch it. See how difficult it can be to catch the ball? That's because I need both my eyes to show me where the ball is in space and how fast or slow it's traveling towards me. And that's what makes the stereo mission so great. By using two satellites, we can see exactly where the solar eruptions are, how fast they're moving, and where they're going. For the first time, scientists were even able to tell what shape some of the eruptions were.
The basic idea is things don't look the same from different points of view, and motions don't look the same from different points of view. But if you put those two points of view together, you can actually understand, for instance, just where something is. I've mentioned that people, of course, have two eyes for binocular vision, which gives us a lot of information about where things are. If you're only looking with one eye and you don't know how big something is, you really can't tell how far away it is from you.
That's right, Globey. Having two sets of eyes, or two satellites, can definitely help us see things more clearly and have a better understanding of where things are and how fast they're moving. NASA's stereo satellites are definitely looking out for you and me, keeping an eye, or a pair of eyes I should say, on the sun.